Hi everyone, in this video I will discuss the second formula that we can use in solving arithmetic series problems. So let's talk about this formula. If the first term, the common difference and the number of terms are known, then we can use this formula. Okay, let's have this example. What is the sum of the first 20 terms of the arithmetic series 7 plus 3 plus -1, -5 plus -5 until the 20th term? So that's the formula we'll be using. Our n is 20. Our first term is 7. Our common difference is 3 minus 7, which is equal to -4. And then after this, let's just replace n, a sub 1, and d by their respective numbers. Okay, so that's what we have. We have 20 as our n, a sub 1 as our 7, d is -4, n is 20. So we can, solve that. That's 14, right? This 20 over 2, that's 10. And that is equal to 19. Okay. Next is, let's just solve this. -4 times 19, that's -76. And then add that to 14. But since they have different signs, we will subtract them. And the result is -62. And then finally multiply 10 and -62. The answer is -620. Okay. Let's go to the next example. In this problem, what's missing is the first term. Okay, so the sum of the 51 terms in an arithmetic series is 2,703. What is the first term of the sequence if the common difference is +2? So we don't know A1, right? What we know is that there are 51 terms in the sequence, and the sum of all those 51 terms is equal to 2,703. Our common difference is +2. So just replace those variables by the respective values or numbers. We have Sn, which is 2,703. We have 51, which is our n. We don't know a sub 1, the first term. Okay, so this is equal to 25.5. That's equal to 50, right? And if we multiply those two, the answer is 100. And then the next step here is, yes, that's 100. And then divided by 25.5 on both sides. So we can cross that out. This is the result. And then subtract 100 on both sides. So we can cross that out. 106 plus -100 is 6, or 106 minus 100 is 6. And finally, divided by 2. Cross that out. The answer is 3. Okay? So this is another problem that, we can use the formula. Next, the sum of the 19 terms in an arithmetic series is 1,235. What is the common difference if the first term is 2? This time, what's missing is the common difference. So we don't know that. This is the formula that we will be using. The sum of all those 19 terms is 1,232. Our first term is +2. And there are 19 terms in this series. So next step is just replace these variables by the respective values. Sn is 1, 2, 3, 5. Our n is 19. Our a sub 1 is +2. Our n is 19, and we don't know d. So 19 minus 1 is 18, times d is 18d. 2 times 4 is, or 2 times 2 rather, is +4. That 19 divided by 2, or 19 over 2, is positive 9.5. Next, let's divide both sides of the equation by 9.5. Cross that out. The result would be 130 equals 4 plus 18d. Next would be subtract 4 on both sides. So we can cross that out. And the result is 130 minus 4 is 126 equals 18d. And then divide both sides by 18, right? So the answer is positive 7. Okay, let's have another example. Okay, I think this time I will be using a different formula, the formula I discussed in the first video about arithmetic series. Okay, so here what's missing is n. Okay, so we're done with uh, a problem who's missing is the first term, and then the previous example, what's missing is the common difference. And here, there are two problems that I will be giving you wherein the missing variable is n. And then here's the first one. How many terms are in an arithmetic series if the sum of the even integers from -7 to 76 respectively is 1394? Now in this problem, um, of course, you're thinking, what formula are we going to use? Well, that depends on what is given, right? Because in the two formulas that we have, okay, so the first formula is for the sum or for the arithmetic series is this. And then the next is this one. Okay, so which formula are we going to use? Well, that again depends on the given. So let's see what we have here. How many terms are in the arithmetic series if the sum of the even integers from -7 to 75 respectively is 1394? Okay, we know S of n. Okay, so that's 1394, right? Sn is 1394. Okay, let's see what are the things that we can have here. Okay, even integers. So that means our common difference here is positive 2, right? So we are skipping, therefore our D is positive 2. And then from -7 to positive 75, we can conclude that the first even integer there is -6, right? -7 is not even, so after that is -6, and that's our first term. And then the last term, we can also see the last term here. Well, it's not mentioned in the problem, but by just looking at this phrase here, we can conclude that the last even integer in the series is 74, right? So we have S of n, we have D, we have A sub 1 and A sub n. Now let's look at the formula. The first formula, we have, of course, what we don't know n, right? That's the problem. We have S of n, we have A1 and AN, right? So I think we can use the first formula, but let's try to check the second formula. So you have Sn, we have A1, which is the first term. We also have the common difference, right? Now, therefore, we can use either of this, okay? But since the first formula, this formula is obviously simpler than the second one, then we will use the first formula, okay? So let's replace that Sn by 1394 and over 2 times -6 plus 74. Okay. So -6 plus 74 is equal to what? That is right. It is equal to 68. Okay. So here we can divide 68 and 2. What is 68 divided by 2? That is right. It is equal to 34. So it is 34n 1394. Then divided by 34 on both sides. Our n is equal to 41. Okay? Let's go to the last example. The sum of the arithmetic series -3 plus -5 plus -7 plus -9 until the last term is -575. How many terms are in the sequence? Okay. So let's compare again, or I will write again the two formulas and let's see what formula we can use to solve this problem. Okay. We know that the sum of those, again, what's missing here is n. We know that the sum of the, or we know that the sum of the arithmetic series is -575. Okay. We know the first term, which is -3. We don't know the last term here. It's not, although we can, you know, use the formula for the finding the indicated term in an arithmetic series to find the last term, but we don't know also n. So I think we can't use that formula, right? I mean, I'm talking about, since we don't know a sub n, therefore we cannot use this formula, right? We have d. Well, it's not mentioned here, but if we subtract -5 to -3, right, that would give us -3. That would be -5 plus 3, which is equal to -2. Then therefore we can have d, right? So we have s of n, we have a sub 1, and we have d, which is -2. I think we can use the second formula. So we have -575 equals n, we don't know that, 2 times -2 plus, no, not -2. 2 times -3. Plus -2 times n minus 1. Okay. So we have -575 equals n over 2 times -6 plus -2n, right? We will distribute that -2 to n minus 1 plus 2. Okay. We can combine -6 and 2. That is equal to -4 plus, now we can just write minus 2n. Minus 2n. There you go. And then let's distribute this n over 2 to -4 and -2n. So this is equal to -575 equals -2n minus 2n squared. So basically what happens here is, if you multiply n over 2 to -4, that will be equal to -4n over 2. So 4 divided by 2 is -2. And then 2 times -2n is -2n squared over 2. So 2 divided by 2 is 1. So that means that should be n squared. Okay. And then let's move this n squared and 2n to the left side, right? we can cross that out. That will be 0. So now we have n squared plus 2n minus 575. Okay. Now how can we solve this? Well, obviously this is a quadratic equation, right? Okay, so one of the ways that we can solve quadratic equation is by factoring. So that means we need to look for the these two numbers, okay? Two numbers that when we multiply, the answer is -5 or 575, okay? But when we add them, the answer is positive 2n. So what is that? Hmm? That is right. It's 23 and 25. Okay. So we can write that as x, yx should be n. So we have n minus 23 and then n plus 25. Again, why did we choose 23 and 25? So because negative 23 times 25 will give us negative 575, and if we add 25 and negative 23, that will give us the second term, which is 2n, right? Or positive 2. And then let's just equate this to 0 and solve for n. Minus 25 minus 25. So n equals negative 25. Here we have n minus 23 equals 0. Plus 23 plus 23. Cross that out. N equals positive 23. Now here we have two possible answers, but we cannot choose negative 25 because we're talking about number of terms in a series. So the answer is 23. Therefore, there are 23 terms in this arithmetic series. Okay, there you go. Thank you for watching. Have a nice day. Bye.